Okay, if you've been following the notes, you know something about integrations. It tends to be quite difficult. And some of the optional problems I was giving you in the past were partial fraction problems where you had things that looked like this, and they were really tough to get through, by the way. But we did get through some of those, including things, I think up to x to the 6, 1 plus x to the 6, by the way. I really can't remember offhand exactly what it was, but we did some pretty outrageous partial fraction problems. So the way I'm looking at this one over here is they want to do a power expansion, power series for expansion of this over here. So what I want to do is remind you that I have something like this over here, 1 minus u is going to be 1 plus u squared plus yada, 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 provided the absolute value of u meets this condition over here. So I want to write that down. So it's going to be 1 over 1 plus x to the 5. I'm going to write that so it looks like this one up here, which would be 1 minus x to the 5th power. And I can just plug it in here. What do you get over here? You would get 1, and then, you know, the u is minus x to the 5, so minus x5. Then it's going to be plus, that's going to be x10, and that's going to be minus, well, I'm going up by multiples of 5, of course. It's going to be 15, and then x20, yada, 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 yada. What does this mean? This condition is x to the 5th power, the absolute value of it, so I'm just going to get rid of the minus 1, has to be between 1 and minus 1. So I'm going to say the x here is between minus 1 and 1 for this to hold. And by the way, I see that over there. All right? So I'm going to think that maybe the integration might be easy if I use the power series for it. So the integration of this one over here is going to be the integration of that thing there. And I think I can do it. And what do you get there? You would get x. Oh, you know what? There's a constant, so I'll put the constant down first. Then you get plus x minus x to the 6 over 6 plus x to the 11 over 11 minus x to the 16 over 16 plus, I'm sorry, that's a 20 there, x to the 21 over 21. And I'm going to say yada, yada, yada. Let's write down the series. And the series for this one over here, this is going to be, let's see, 1 plus x5 dx is going to be equal to c plus, all right, let's write this down. And I'm going to start at 1. N equals 1. Let me see if I want to do that, though. Because I'm starting to realize that you got, you know, they're going up by multiples of 5. So before I start, I'm going to put x is going to be 5n plus 1. So I'm going to start at 0. All right? So someone says, why are you starting at 0? Because if I do 0, I'd get the 1, then I get 6, and then 11, get 16, 21. Let's put the minus 1 in. Oh, this goes up to infinity, by the way. Minus 1. And, yeah, this is going to be fine. N. And what goes on bottom? Well, let's take a look at that. It looks like 5n plus 1. All right, let me just say I did that right. And, yeah, I think so. Let's look at our k and see if we got that. All right, so c, which sometimes I forget. And then I got this business over here. Minus 1 to the n, I got that part. I got this part, and I got this part over here. All right, so I do want to point out there's that this is going to hold for what they said it's going to hold for, which is between minus 1 and 1. And they're not asking me to do anything with the endpoint, so I'm not going to do that. So we're good. We're good. We got it. Thank you.